Hey y'all, I just decided to make a quick tutorial on the different ways you can simulate stuff on RCAC. So the example I use will be Nemo 5, and the script I'm running will be BOGBS. I think it's probably stand for bilayer graphene band structure. So I create two folders here. That's for the two different methods we're going to talk about. So the easiest one would be run in terminal. All you need is your inputs deck. They kind of look like this. I've already set it up. So what I'm going to do is I'm just going to put in the executable. I'm calling Nemo, and then we'll do BLG BS reformat.in. Oh, we need to load stuff. You can find the module load instructions on NanoHub in the group. So those are the settings I would need. Now we can do the whole Nemo thing again. This one. And we'll see. We'll wait a couple seconds. And there, we finished the entire simulation in 2.14 seconds. This method is not advised because according to Purdue RCAC's documents, the computing resources for the front end was designed to only facilitate the rendering of the desktop. And if we're running a very heavy load simulation, it will slow everybody's like client window down. What we generally recommend to do is to use a command called sbatch. With the sbatch, you are using the actual CPUs, cores, or nodes dedicated to actually do the heavy lifting. Before you run anything using the submit method, you want to go in and find out what kind of queues you're on, and the command is slist. So here you can see that I have a debug queue, GPU queue, high memory cube, NCN cube, and standby queue. Standby is the standard queue that are almost accessible to all the users. The wall time is only 4 hours. Debug is to help you check if there's any problem with your code. Usually, you don't have to wait for very long on this queue before your job gets taken, but the wall time is only for 30 minutes. I don't know too much about GPUs. I never used GPUs. High memory. Well, this one has 24 hours of wall time. What's special about it is that it has 1 terabyte of memory for computation, and sometimes you will need more than the standard 250 gigs of memory in type A node. NCN, these are nodes for the NCN organization. I think they probably purchase like separate computational power, and that's why this is a very generous queue of 14 days. And all of these CPUs, cores, or nodes are only accessible by the NCN members. If you have really big jobs, or when all the other queues are really full, like right now, there's 260,000 requested cores, but there's only around 2,000 cores available. Get on NCN, this is your dedicated lane for computation. Okay, so that's about all the queues. Now let's move back to the actual submission procedure. The input deck should be the same as the one before. What's special is that instead of just running it on the terminal, we will write a submit script to specify everything we would like to request from these powerful computational nodes. You won't have to add any of these. I commented them out. I don't think these features are available in Negishi so far. These are not commented out. They are the SLURM formatting. The first line is saying we are requesting 1 node, and within the 1 node, we want 4 cores. This is specifying time. I will use up to 30 minutes of computation. This is specifying the queue. I want to go on debug. And these are some other informations you can put in so that you can identify which runs you're doing. If you would like to generate the output file and the error file, they're over here. Now we move on to the main text for submission, so to speak. So these 5 lines, they are whatever is being specified on the NanoHub wiki page. So you definitely want to put them in. This is just something I do. I would like to track when does the simulation start and when does it end to have a better gauge on like how I set the wall time in the future. I think this is one of the standard lines you have to put in. I'm not sure what it does, but there are documentation about this on the RCAC's website. Onto the actual simulation. We're using MPI, and we're saying we want 4 cores for the MPI. And of course, this is the address to the Nemo executable. And this is our input stack, just like how I specified that in like run and terminal part of the video. These are the output files. You can refine these a little bit. You can even take them out depending on how much information or how much clogging you want in your output. And then this is just to record the end date. The way you use the submit files is to do as batch and then include the .sh file. So submit nemo.sh. And this sq-u plus your username, this is how you can check the status of your job. It will give you a job ID. It tells you the user, which queue you're on, the name you remember. This is one of the things we specify at one of the SLURM headers. We requested 1 node and 4 cores out of the node. Time limit is 30 seconds. The status currently is running, and we have been running it for 3 seconds at the time of executing that command. When we execute it again, it should be finished by now. And if you refresh your directories, you'll see all of these results output from the computation. We can go into error, I believe. This would be equivalent to the terminal output when we're just running everything in terminal. And so you see we're only spending 1.62 seconds instead of the 2.2 seconds before. And that's because we're using more cores on that. And yeah, that's a very short intro on how the 2 methods of running a NEMO simulation script on RCAC.